So in this video, I want to talk about one of the example of SAT math problem. And the question is, the table shows some value of the linear function f right over here. And we can see that it is a linear function, which means if we graph it, it will going to be some line on the coordinate plane. And then the question is, which of the following defines the function f? And there are some choices right over here. And we can see that according to a function definition, the x values will going to be input and the y values will going to be output. And I'm going to talk about it later. And at first, we can also see that x and the y values, if we graph it, it will going to be somehow some coordinates. So at first, we also need to think about in terms of the relations between coordinates and the function system. So let's think about in terms of a function of this question. For the function of this question, they already mentioned about it, which will going to be f in this case. And for the function, it sometimes contains a factor of that function or not, but in this case, it contains, which will going to be n in this case. And it will contain a specific equation, but that's the thing that we want to find in this problem. So let's think about in terms of how function works. So there is a function, and for the function, it always requires a input. And if we input the value to the factor of the function, which is n in this case, there will be a specific output. And this is how the function works. First, let's think about in terms of a form of linear function, the linear function right over here. So for the linear function, it will going to be y is equal to mx plus b. And I want to talk about these things right over here. And let's think about in terms of a x value. The x value is a variable, which means it changes all the time. And let's think about in terms of a m. So let's say there is a function and the m is a slope of the function. And for the b in this case is a y-intercept. The y-intercept means the x value is equal to 0 and the y value will going to be some numbers. So I will call it y. And for the y in this case, it will going to be a output of the function. So m and b are on variable. They're variable. On variable depends on a function, but the x is a variable. The x value is variable, which means it always changes. That means this function will gonna be changed, which means there will be a different output depends on the x value. So let's think about in terms of how to find the m, which is slope in this case, and we need 2 points to find it. Let's say there is a point x1 comma y1 and then x2 comma y2. The reason why I wrote x1 and then x2, y1 and y2 is not to be confused with each other. And we need to see that this coordinate and this coordinate will going to be different. So the way to find the m is we apply y2 minus y1 over x2 minus x1. And this is how to memorize it. And this is how to solve for the slope of this function. So all we do is we pick some particular 2 coordinates and we subtract y2 from the y1 and we subtract x2 from x1. And that shows how the coordinates change from each other. That means the m, which is the slope of the function, just literally just shows how steep is a function is. So we needed our answer for this question was C, and let's think about it in terms of a graph of this function. So at first we can write our function down. So our function is equal to f of n, where y in this case, or we can write f of n, and that should be equal to 3n minus 5, as we have found it right over here. And it is a linear equation, linear function, and that means we need two coordinates to graph it. So two coordinates to graph. So at first, let's pick some easy things. So we know that y, or f of n, is equal to 3n minus 5. Let's think about it when n is equal to 0. Well, when n is equal to 0, it is a y-intercept, which we knew it right over here, that it is minus 5. So we can write it in our coordinate 0, comma, minus 5. And we can pick one more graph, one more coordinate that is easy to graph. It will going to be when n is equal to 1. When n is equal to 1, 3 times n, so f of n is equal to 3 times 1 minus 5, which will going to be 3 times 1 is 3, minus 5 is negative 2. So we can graph it. So let's say here 1, 2, 3, 4, and then 1, 2, 3, 4. So if we graph it 0, comma, minus 5, it will going to be right over 0, comma, minus 5 right over here. So here, right over here is 0, comma, minus 5. And we need one more point, which will going to, when n is equal to 1, the f of n is equal to negative 2. So 1 and then negative 2, which will going to be right over here. So this point right over here will going to be 1, comma, negative 2. And if you graph it, it will going to be something that look like this. So if you graph more clearly, it will be something more like this that passes through our points right over here. And we knew that it is a linear function. So we found that the linear function right over here are based on our function f of n is equal to 3n minus 5.